Hey math kids, today we're going to talk about how to figure out your average rate of change on your data by using the equation. So you might be wondering, why am I showing the graph? We need to create those symmetric intervals again, so I just want to go over that real quick. So what you're going to do, you're going to find your high point, and that's going to cut your graph in half, and then you're also going to mark your x-intercepts, which are right there, and then we're going to figure out how far apart those are on the x-axis. On mine, I count 18 squares, and so if I just count over 9, or half of that, that's where I got this point, and then if I go from here and count 9, I get this, and then if I count 9 more, I should end up right here. So that's how I did on mine. It's not always going to be 9 for you. It's whatever it is. Now, what I did is I went through and I wrote down the x values in between these two. So the x value right here is negative 0.2589, but I just rounded that to 0.26, negative 0.26. The x value right here is 0.2. Now if I go from here to here, it's 0.2 to 0.65. Once again, I rounded. And then from here, 0.65 to 1.1, and then 1.1 to 1.6. Once again, rounding. Okay, once you have those intervals, write them next to the equation. So this is the equation for my graph. There's actually a negative sign right there. And then what you're going to do is you're going to go to Desmos, but instead of going to the graphing calculator, you're going to click right here, Math Tools, Scientific Calculator, and you're going to set this up. So just start by typing in your equation. It's going to tell you that it doesn't like that there's an x in there, but that's okay for the moment. Okay, so this is just the formatting. Now, what we're going to do, because we want to plug in our x value to get our y value. So if we plug in x1, we get y1. If we plug in x2, we get y2. And so if we go back to Desmos, we just change that x with negative 0.26, which is our x value. It tells us our y value right here. So negative 0.03. Okay, now we go back to Desmos. This time change that value to 0.2. Now keep in mind, if you use your standard form equation, you're going to have two x's and you'll need to change both those x's. So using the vertex form is a little bit more efficient, but you should get the same answer either way, so it doesn't really matter. So 9.5 is what I got on that one. Okay, and then we plug that into our y2 minus y1 over x2 minus x1. Okay, and what I do is I open up another tab of the same thing, and I just set up the format like this. Just do sets of parentheses being divided by, here actually, let me just show you that. So I actually start by doing that. So two parentheses divided by two parentheses. When I go up, do minus, go down. That way it creates a line, the division line, a little bit easier. Okay, so my y2, which is my first value, is 9.5. My my y1 is negative 0.03. My x2 is 0.2, and my x1 is negative 0.26. Okay, I don't have to hit enter or anything, and I would suggest not hitting enter. It gives us 20.7. Okay, So that's the average rate of change for the first section right here. So if we just look like on the last video, we got about 9.5, which was our rise. We divided by 0.46, and so that's going to roughly double it. I'll just open up this calculator real quick to test that, to see how close we were. 9.5 divided by 0.46, and that's 20.65. And what did we get again? 20.7. So that's really close, right? Okay, so that's a good sign that we're getting the right answer. Okay, now something to notice. We've already plugged 0.2 into this equation, and that happened to be this stream right here. And so this is my x1 now, this is my x2, but my y1 is just going to be the same thing right there. So that's 9.5. I don't need to plug that in again. But I haven't plugged in 0.65 yet. And so I need to go back to this one, plug in 0.65, and that gives me 12.7. Okay. Now we're going to plug those values into the second thing. Get rid of all of these. Okay. Now we want to remember we're using this over here, so it's y2 minus y1. So y2 is 12.7. y1 is 9.5, and x2 is 0.65 and 0.2. Okay, we see that that's 7.1. And so that's the average rate of change on there. Once again, that is describing the slope from here to here. Okay, now we're going to try this again. Let me change colors. Okay, so this is x1, x2. We want to find our y1 and our y2. And so since it's 0.65, 0.65, if we were to plug that in, we know we would get the same answers right there. Now we need to plug in 1.1. So we go to this one, plug in 1.1, and that gives us 9.7. Okay, now we do the process again. I like to keep my formatting like this. It helps me keep all the numbers straight. Okay, once again, going back to this green thing, it's y2 minus y1. So my y2 is 9.7. My y1 is 12.7. And let's see, my x2 is 1.1. Okay, so we didn't get exactly the same answer. But some of that could be due to the rounding that we did. They're fairly close. So it's 7.1 and 6.7. We were expecting it to be close but negative, and that's what we got. Now the next one we're expecting to be close to 20.7 but negative, because if we look at the graph, this slope should be the same as this slope. It's just one's negative and one's positive. So let's see what happens with that one. Okay, once again, this is my x1, this is my x2, and when I use x1, I want to find my y1, and then my y2. Okay, so once again, plugging in 1.1 gives us 9.7, because it's the same as right there. Now we just need to plug in 1.6 to this one, and that gives us negative 0.9. Okay, we jump to the other calculator, clear out the values. Okay, so once again, we're using this y2 minus y1. And so my y2 was negative 0.9. And then 9.7. And then x2 is 1.6. And then 1.1. Negative 21.2. And we see that these were close, but not the same. They should be close, but opposite signs. And that's all we need to do. So we describe the average rate of change using an equation of our data. If you need additional help, please come to MathLab. Until then, calculator.